Hello class and welcome to another lesson. Today what we're going to be talking about is equations of lines. This is section 2.2 through 2.4. So we're going to cover these two lessons in a matter of about 3 days here. So there's going to be quite a few video lessons on 2.2 and 2.4. So what we're going to talk about today is the equations of lines. Just to review from geometry, let's just talk about what a line is. And it might sound pretty basic, but let's just talk about the mathematical definition of what a line is. A line is a straight figure. It's a straight figure made up of points. You don't have to write this down if you don't want to. I just want to write it down so you guys can see it. So if you think about this for a second, a line is a straight figure. So picture a straight line. And it's going to go infinitely in both directions. So it's going to go infinitely to the right, and it's going to go infinitely to the left. So this figure right here is not a line. A line does not have any curves in it. It is completely straight. Lines obviously can have slope. It can go up and to the right, and it can go down and to the right. But just so you guys know, it doesn't have any curves in it, and it's made of an infinite number of points. Here's a point right here, and here's a point, and here's a point, and here's a point. And as we continue going to the right, which lines continue to go for an infinite distance, line segments come to an end, but lines never come to an end. So because the line goes for an infinite distance, it's made up of an infinite number of points. We're going to talk about 3 equations of lines today. And I believe that you guys have been introduced to all 3 of these, but it's good for review because these equations of lines come into a bulk of things that you're going to do outside of high school, because many relationships in life are linear. You guys are going to find that when you go into a business of some sort, a lot of times the real life situations that you come in with are linear situations. So it's very, very beneficial to learn all 3 of these equations of lines. The first 2 that we're going to talk about are on this yellow slide. It's going to be point-slope form and slope-intercept form. These are named, obviously, because of what it tells you. This one has a point and it has a slope. The point is x1 and y1, and the slope is m. So when it says point-slope form, it means that you're given a point, and it means that you're given the slope. Hence the name. This one is the slope-intercept form, and that is because you are given the slope, it is m, and you are given the y-intercept. That's why it's called slope-intercept form, and the intercept that it gives you is the y-intercept. So slope-intercept, that is our b. So if it gives you the y-intercept and it gives you the slope, you put it into slope-intercept form. If it gives you the point and it gives you the slope, you put it into point-slope form. Pretty basic, I think, just by giving us the names. So now when it says, what do each of these variables mean? Well, I've already told you a couple of them, and I'm sure you guys have been familiar with them before. Let's first talk about what m means. This letter m right here, and this letter m right here. M in this case means our slope. We're going to talk about this more in depth in later lessons, but our slope can be positive, meaning it goes up and to the right. It can be negative, meaning it goes down and to the right. It could be 0, which means that it is completely horizontal, or our slope could also be undefined, and an undefined slope is a completely vertical line. So that's what we have for slope. M is slope. So whenever you see an M, that is slope. So that takes care of this letter, and that takes care of this letter. Let's next go on to B, which we talked about earlier in this lesson. B is our y-intercept. So what our y-intercept is, just as a reminder, you have an x, y coordinate grid here, and if we have a line that looks like this, our y-intercept is where it crosses the y-axis. So here's where it crosses the y-axis. There is my y-intercept. I might have a line that looks like this, in which case my B, or my y-intercept, would be right at that point. So it's wherever it crosses the y-axis. Here is my y-intercept on that green line. So whenever you see the letter B, that is our y-intercept. It's where it crosses the y-axis. So that takes care of this letter. Let's next talk about x1 and y1. It's located right here, y1 and x1. What this is, class, is it's an ordered pair. So we're talking about x1 and y1. And not only is it an ordered pair, but it is a specific ordered pair. Class, make sure that you write this down in your notes. This is very important. I promise you, you're going to see it again. So x1 and y1, this is an ordered pair, and not only is it just any ordered pair, but it's a specific ordered pair, such as maybe this point right here. We'll say this point is right to, up to. That's where this point is located, right to and up to. So this would be my x-coordinate, so we're going to call it x1, and this is going to be my y-coordinate, so we'll call it y1. So x1 is 2 and y1 is 2. You could have an ordered pair right here. Let's say it's left 1, 2, 3, 4, 5, 6, 7, and let's say it's up 1, 2, 3. So this is left 7, up 3. So this is a specific ordered pair. We would call this x1 and y1. It's strictly one x-coordinate and one y-coordinate. So it is a specific ordered pair. So that takes care of x1 and y1. So our last two letters are y and x. Y and x, which are the same in both equations. X and y is also an ordered pair. However, in this case, it's not a specific pair. It represents every ordered pair. It represents every ordered pair. So just to give you an example of this one, we said that a line has an infinite number of points. So here's my xy coordinate grid, and here is going to be my line. And this line has an infinite number of points on it, and I will just draw, oh, I don't know, maybe I'll draw 10 of them or so. So here's all these ordered pairs. And I could label all of them, and then they would be specific ordered pairs. However, I can just call all of these x-coordinates and y-coordinates, and I could have an equation that satisfies all of these x and y coordinates, in which case the x and y are going to remain unknown in our equation because they represent every single x and y ordered pair that lies on that line. And once again, there's an infinite number of them. So that's why we leave that unknown in our equation, because there is infinitely many of them. So those are our letters that we really need to know. Hopefully the M and the B are very, very common sense for you. You've had them before, so hopefully it's just review. The M is the slope, and the B is the y-intercept. M is the slope, B is the y-intercept. X1, Y1 represents one specific ordered pair, and then X and Y represent every ordered pair. So that's what we have for our letters. So now let's get on, let's talk about standard form before we get on to our example problems. We have three forms of lines: point-slope form, slope-intercept form, and this is our third one in standard form. Standard form is written in ax plus by equals c, where a, b, and c are all real numbers. So real numbers, that means that we cannot have any fractions, we cannot have any decimals, they are real numbers. So we have a couple rules with standard form. Let's briefly talk about them. First of all, the greatest common factor must be a 1. So an example of this, as you can see up here, if you somehow get this for a line, which is possible, 2x plus 4y equals 8. if you get 2x plus 4y equals 8, all three of these coefficients are even numbers. If all three are even numbers, that means they can all be divided by 2. So we could take out that greatest common factor of 2 and reduce it. So we would divide this one by 2, divide this by 2, and divide this by 2. So your correct answer would be 2 divided by 2, making a 1x, 4 divided by 2, making a 2y, and 8 divided by 2, making a 4 on the right side. So make sure you recognize that as you're going through your work. Make sure that all your coefficients are reduced to their greatest common factor. All right, the next rule is that the leading coefficient cannot be negative. So if you get something like this, a negative 3x plus 4y equals 7, that coefficient in front of x can never be negative. That's just one of the rules of standard form. So if that's the case, what I kind of consider, if you have a negative 3x plus 4y equals 7, what you can do is you could just divide every one of them by a negative 1. Because a negative divided by a negative is a positive. So then if you take a negative 3 divided by a negative 1, this now makes a positive 3x. A positive 4y divided by a negative 1 is a negative 4y. And a positive 7 divided by a negative 1 is a negative 7. So if you want to consider it as just dividing by a negative 1, that's what I do. That kind of helps me out. And then you would know that your leading coefficient is positive, so it doesn't matter if the other ones are negative, as long as the leading coefficient, which is the number in front of x, is positive, you're good to go. Another way that a lot of students think of it is, if the leading coefficient is negative, just change the signs on all of them. So we're talking about this equation again. If the leading coefficient, which is a negative 3, if that's negative, let's just change the signs on all of them. Positive, negative, negative. And then you are good to go. You are having this nice smiley face right here. Last rule for standard form. And once again, class, make sure you take good notes on this, because I promise you, you're going to see this again. So, the coefficients must be integers, which means that there are no fractions and no decimals. So, if you ever see a fraction, such as this, if you ever see a decimal, such as this one right here, what you have to do is you have to get rid of that decimal, multiplying every single term by a number. On this particular one, they just multiplied every single term by 10, which means that you just move the decimal point over one spot. This becomes 5x, this becomes 15y, and this becomes 7. Just make sure you're consistent with everything. That's the most important thing. So you can't have any fractions and you can't have any decimals. All your coefficients must be integers, which, just as review, integers are all the numbers on a number line that are not fractions or decimals. So when you think of a number line, you think of a negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, so on and so forth. Those are our integers. They don't have any fractions or decimals. So now that we know those rules, we're going to go through each and every one of these problems, and we're going to state our point slope form, our slope intercept form, and our standard form. And hopefully we can tie in all three of these slides, all two of these slides rather. Hopefully we can tie these two into what we've been talking about now that we're on problem number 1. So this one, write the equation of the line with the given information. It says that this line passes through the point 2, negative 3, and it has a slope of a negative 2. So it passes through the point x and y, 2, negative 3, and it has a slope of a negative 2. So class, this might sound a little bit redundant and it might sound silly, but I really want to do this to get it into your brain so that it stays there. You have a point and you have the slope. You're given a point and the slope. You're given point slope. You're given a point and the slope, which is point slope. What equation do you think you're going to use? Ding, 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 ding. I'm sure you guessed it. You're going to use the point slope form. If you're given the point and you're given the slope, hopefully that just tells you I got to use point slope form, which is y minus y1 equals m times the quantity x minus x1. We know that our m is a negative 2. And then our specific ordered pair, we said that was x1 and y1. So x and y represent every ordered pair. X1 and y1 represent a specific ordered pair. So once you have your information, all you do is you just plug it into the formula. Y minus the y coordinate. So y minus this y1. Y minus a negative 3. That equals my m, which is my slope, negative 2 times the quantity, x minus the x coordinate. And the x coordinate is 2. So we're almost done. All we have to do is clean up this y minus a minus 3, which, as you I'm sure have seen, it kind of sticks out like a sore thumb. Y minus a minus 3 is the same thing as y plus 3. So we have y plus 3 equals a negative 2 times the quantity, x minus 2. And class, this is our point slope form. So on the very bottom of your, or on the, I guess on the right side of your note sheet, you see point slope form, slope intercept form, standard form with blanks next to them. This one is the answer for point slope form. Alrighty, so now the next blank, it says it's asking for slope intercept form. And slope intercept form is this one right up here. It is y equals mx plus b. So as you can see, we have to get y all by itself. This means isolate the variable, and the variable we want to isolate, which means get all by itself, is the variable y. So let's get this y all by itself. Okay, let's get that all by itself on the left side. One thing you might also notice is in this formula, y equals mx plus b, there are no parentheses. I don't see any parentheses in this. Do you? I think not. So let's get rid of the parentheses by using the distributive property. So we're going to distribute this negative 2 to the x and to the negative 2. So we're going to have y plus 3. That equals a negative 2 times x is a negative 2x. A negative 2 times a negative 2 is a positive 4. So I have successfully distributed. Now I want to isolate the variable. Let's get y all by itself by subtracting 3. So if I subtract 3 from this side, I'm going to combine like terms. I'm not going to subtract 3 from here because I can't subtract x's with constants. So I'm going to subtract 3 from the 4. That would just be combining like terms. So I have y all by itself now on the left side, and I have a negative 2x on the right side, along with this 4 minus 3, making a positive 1. And class, you have successfully put it into y equals mx plus b form. Y equals a negative 2x plus 1. This is our slope intercept form. This is our slope intercept form. So you're 2/3 of the way done. You have your point slope form. You have your slope intercept form. The last one is our standard form. So in our standard form, going up to the top here, looking at our equation, our standard form has ax plus by equals c, where a, b, and c are our coefficients, and x, y, once again, represent every ordered pair. Those stay unknown in our formula. So a and b have to be on the left side all by themselves. A is the coefficient in front of x, so here is a. B is the coefficient in front of y, so here's b. We assume it's a positive 1. It's 1y. So I want to get all of my x's off to the left side, because ax plus by equals c is going to be my formula for standard form. And this is my c, by the way, the constant, the one that's all by itself without a variable with it. That's my letter c. So as you can see, how do I get this negative 2x off to the left side? Well, I simply have to add it, correct? Because then I would have 0 x's over here. So then I have to add 2x to the left side as well. So if I add 2x to the left side, I get 2x plus this y right here, plus 1y equals a positive 1. Now what you always want to do after you have the x and the y on the left side all by itself with the constant on the right side, what you should always ask yourself are the three rules of standard form. Is the greatest common factor 1? Yes, your coefficients are 2, 1, and 1, so your greatest common factor is 1. That step is taken care of. Your second rule, what's your second rule again? Your leading coefficient cannot be negative. Is your leading coefficient negative? It is not. Your leading coefficient is a positive 2. So that rule is out of the way. The third rule says that there cannot be any fractions or decimals. Your coefficients all have to be integers. And are they? Hopefully you say yes. Your coefficients are 2, 1, and 1. Those are all integers. So you can circle your answer right here because this follows all the rules of standard form. So you have your answer for this one. Kind of three answers for one problem. You have your point-slope form in green. You have your slope-intercept form in blue. And you have your standard form in red. And this is what I expect from you on all these problems for today. This is what I'm going to expect from you on a test as well. Standard, boy. Writing's tough. Alrighty. So, follow these exact same steps as you guys do number 2 on your own. Pause the video, please. Let's see how you come out with as you do number 2. Alright, now that you've done number 2, check your work with mine, please. Once again, you're given a point, and you are given the slope. If you are given the point and you're given the slope, you're going to put it into the point-slope form of our equation. So it's going to be y minus the y-coordinate, y minus 1. That equals our slope times the quantity x minus a minus 3. X minus the x-coordinate, so x minus a minus 3 is x plus 3. And this is your first answer. This is your point slope. Alrighty, your next one, you want to get into slope-intercept form. So what you're going to do is you're going to distribute first to get y minus 1 equals a negative half x minus 3 halves. Subtracting 3 halves. And then once you do that, you have to get y all by itself, so you're going to add 1 here to the left, and then you're going to add 1 here to the right. So now we've successfully gotten y all by itself. A negative 1/2 x stays there, and a negative 3 halves plus 1 is a negative 1/2. So your slope-intercept form is y equals a negative 1/2 x minus a half. So this is answer number 2 in slope-intercept. All right, let's get down standard form, which in my opinion is the most difficult because there's so many rules that we have to follow. So we're first going to get x and y on the same side. So you're going to add a half x, add a half x over here. So you're going to get 1/2 x plus 1y, so plus a y, that equals a negative half. Now as you can see, your coefficient in front of your x is positive, so that's good. However, you have fractions as coefficients. And in standard form, you can't have fractions. So what you have to do here is you have to multiply everything by the least common multiple. So what do 1/2, 1, and 1/2 all go into? Basically, how do you get rid of this 2 in the denominator? You have to multiply everything by 2. And that would take care of all your fractions. Because 2 multiplied by a half, 2 times 1/2 is 1x. And then you're going to distribute this 2 times everything. So 2 times 1y is a positive 2y. And then 2 times a negative half is going to be a negative 1. So now as you can see, all of your fractions are gone. your leading coefficient is still positive, and your greatest common factor is 1. So this is the answer in standard form. All right, I hope those first 2 examples made sense. I'm going to do a different video for the last 3 problems that we're going to have on our notes for today for problems 3, 4, and 5. So let me know if you have any questions on this stuff, and especially if you have any questions on these equations, because these need to click in your brain in order for you guys to understand this lesson. So if you guys need any more examples or if you need any further instruction, please let me know when you get to class tomorrow.